I'm now showing 5 minutes after, so we're going to go ahead and get started. And there's a lot of really great new stuff here that I think will be pretty interesting for a lot of people. But one of the things that I wanted to do is to go back and start off with the original demonstration that we started doing like 4 months ago that will put things in a lot of context and kind of put a ring around the sorts of things that all of this other stuff is new relative to, and say, yeah, well, all of this stuff is going to work again shortly once we get there. So before we get started, from anybody, are there any questions that we should go over? Nothing heard. Proceeding on. What I wanted to do was to start by doing a review of what does the brain simulator actually do. And I want to recall that there is the UKS, which is a data structure, and then there is this modular software system. And what I'm going to show you first is what's in the current main branch. So this is what's been checked in and merged and is fully functional. And this is what you're going to get if you just log on and look at things. And all of these dialog boxes are dialogues from separate modules. And this is the list of these modules. And you can enable or disable their dialogues and things like that with a context menu dropdown. And over here we have the display of the content of the UKS. And so we can say it's already expanded. So if I start adding data to this, and I was playing around with it to make sure it still worked, and it does. And my go-to example is Fido is a dog. And this creates an entry, Fido is a dog. And this is the add statement dialog. And essentially what it does is it collects the information from these dialog fields, and then it makes a single call to the UKS to do an add statement. And I'll talk about the documentation of that, which is all new. It's a little further down the list. But I wanted to say that if I ask, say, what Fido is, in the query dialog box, I get this list of the hierarchy of things that Fido is. So Fido is a dog, and a dog is an unknown object, and an unknown object is an object, and an object is a thing. Everything derives from thing in this model. The system supports inheritance. So I can say dogs have 4 legs, and it's automatically added a thing called leg, and it says that a dog has 4 of them. And now if I ask for the properties of Fido, I can see that Fido has 4 legs in the query box. And the same is true, I can say dogs have fur. I can also add properties specific to Fido. Fido is brown. And now when I query on Fido, the system interchangeably combines the attributes that are specific to Fido and the one that's inherited, in the same way that when you look at people, you know they typically have 2 legs, And you don't ever have to store that information specific to people because it's inherited from the fact that somebody is a person, that they have 2 legs. And the system, I'm not going to show it, but the system also handles exceptions. So I can say that dogs have 4 legs, and then I can say that Tripper is a dog, but Tripper has 3 legs, and the 3-leg attribute will override the inherited 4-leg attribute. And so in the background, the UKS is doing all of this, I could say logical processing, although there's no logic to it. It's simply inherent in the structure of the way the knowledge is built, that if you inherit things from your ISA ancestors and handle exceptions, all of this stuff works by magic. I want to add to the picture the concept of a clause. Now, when I talked about relationships, a relationship relates 2 things with a relationship type. And the relationship type is also a thing. And the key is, because a relationship type is a thing, you can inherit attributes on the relationship types as well. Everything is interchangeable here. So the is a relationship type, and we can just display the relationship types and see what they are. And as you add things to the data structure, you don't have to do anything to add new relationship types. If you say, in the same way we said that a dog has 4 legs, it created a relationship type under has 4. So 4 being an attribute of this instantiation of this relationship. So the same structure is doing everything you need to do. So in the same way that a relationship relates to things, a clause relates to relationships or more. So I can say Fido can play fetch if the weather if I've got to spell weather right, is sunny. And this creates what looks like a relationship, but is really a clause, because Fido can play fetch if the weather is sunny. And now if I query Fido again, I can say that Fido can play fetch if the weather is sunny. And however, did I put that in right? Yes. And if I look in the data structure, I can see that the weather is sunny because it defaults to being whatever you said when you put it in. But if I say weather is not sunny, now the weather is not sunny, and I should query Fido, and Fido can no longer play. In fact, if I do that and I say, what can Fido play? No results. But if I go back to saying the weather is sunny and redo the query, Fido can play fetch. And so that's an overview of what the data structure of the UKS can do. And you can see that with this manual method of entering data, it's exceedingly tedious to enter data, but this is essentially, these dialog boxes are here so that we can test and make sure the data works properly. And before I move on to the next step, I wanted to say there is documentation for the UKS. And if I go there and here, not there, here is what it looks like. And I was going to kick this into the chat. so that you can look at what the documentation is as we play along here. Chat. Okay. So going back to the screen, so within the UKS, there is the UKS, and by the way, this is slightly out of date, but the UKS itself, which is a list of things, and the things have relationships or clauses, and essentially this is the entire structure of the API. And about, I'd say, 2 or 3 weeks ago, all of this became a DLL. And so this is largely the exposed interface of that DLL. And so you can initialize it and you can add things and delete things. And a little further down, you can do an add statement. And I just wanted you to know that this documentation is here. It's somewhat out of date. I think that's largely because the main branch has been updated a little bit and hasn't been, and the documentation has not been. So it's a couple of weeks out of date, but largely everything that's in here is true, except that because it's a DLL, it's no longer a module. It's simply an item called UKS, where it used to be a module. Now, going back to the brain simulator, I'm going to delete all of this information. Now we're going to move on to the next step here, which is from William. And as I was saying, this is really tedious to enter all of this information. And William has written a module which takes a list of 5,000 common English words and goes to Chat-GPT and gets properties for them. And so he has saved that in a UKS file called 5,000 words, which is online and you can work at it. So that's how long, by the way, it takes to import. There are actually 7,000 words in this file and 20,000 relationships. So you can see that things are pretty snappy with this database size. And at 5,000 words, just to put this in perspective, a regular person speaking English only has a vocabulary of 20,000 words. So this is a representation of about a quarter of the English language common vocabulary. People who are highly educated may have greater vocabularies, but 20,000 isn't a bad estimate. And we can say in this dialog, there's a search box. And let's search for animal. And this is what it collected as animals. And we can double click these and see their properties. There's a panda, a bear eats diverse fish, and a bear has fur. And a number of things that William is still working on is there are still occasional issues where not everything is coming back singularized, but he's going to be able to fix that easily. But here we have different kinds of cardinals. And we got mythical birds. I haven't looked at this, obviously. Phoenix is a mythical bird, which is a subset of a bird. And the system has relationships and the relationships from. So if I look at relationships from, you get a peculiarity, and this is an example of the type of inconsistency that kind of blows up the system, that in the event it said RA instead of is A, you get a kind of bogus information. And one of the things I want to do is to really have a conversation about things that William can add. And I should point out before we did this 5,000 word structure takes a couple of minutes, and it's chargeable on Chat-GPT, and it costs about $1. So we can get, relative to manual entry, there is no comparison about how fast this is and how efficient it is. And even when you have humans doing the data entry in ConceptNet, or is it ContextNet? ContextNet. That
ConceptNet, yeah.
ConceptNet.
ConceptNet, yeah.
Thanks. It was loaded with errors like this, because if one person enters the data, they will enter it slightly differently, and it becomes completely incompatible. And so one of the things, there are two things I'd like to do. The first is to give suggestions to William about how he can tweak the system to get more and more useful and more accurate and more consistent data. And the second is that once we have this data, we need to have agents that will go through and clean it up. And so one of the things that Yeda is going to be working on shortly is a system that will bubble properties upwards into the system, so that if you find out, for example, that if you look at various birds and you find out that they all have common properties of feathers, if an eagle has feathers and a hawk has feathers and a jay has feathers, that you could take this property and migrate it up to bird so it can subsequently be inherited. And this makes the system vastly more efficient, and it also adds properties to other birds where you may not have said that ravens have feathers. But if you find enough commonality to think that birds have feathers, that you bubble this up, and all of a sudden you get a much more efficient mechanism with a lot more implied knowledge in it. So one of the agents we'll be talking about, not today, but down the road, are agents that can bubble information up in the system. Okie dokie. So this is in a branch called Online Info, and the code is really simple and straightforward, but there is a training process called fine-tuning that you can use with Chat-GPT, and I don't know anything about it, but it's what helps give us more consistent information. I see another error while we're looking at it, that a bird is a bird.
Yeah, I have a question, Charles, about this.
Sure.
Well, that one actually, that's not my question. That one you can easily get rid of. Just stop the thing from biting its own tail. But what I was going to ask is the categorization. Is it done in C# or is it done also by Chat-GPT?
Chat-GPT. Okay. Chat-GPT is one of the things that he has specifically tuned the system to respond to answer. Is you say, tell me about a bird, and he has modeled bird is a as one of the results.
Right.
And so
Okay.
that's coming directly out of Chat-GPT, and it's pretty much unedited.
Okay, so all the bird is or something else is a bird, and then just put all of that in the at the same level of the tree, right?
I didn't understand what you said.
So like if you prompt ChatGPT to answer what is a bird, right?
Oh,
And
yeah,
then
yeah, yeah.
ChatGPT
Okay.
says all of these things is a bird, so you just put all of them at the same level of the tree, right?
Only you don't have to do a thing. If you
Right, right,
say X
right.
is a bird and Y is a bird, then X and Y will automatically be descendants. And I did want to illustrate this circular reference is perfectly allowed. You just have to be a little careful that if you put yourself in a recursive program method in an agent, that you've got to set a limit on it, because human information is loaded with circular references. And if you want to have a system that has human kind of intelligence, you have to be able to just accept that circular references exist. And I found that they also exist in logic and explanations. Today is a good day because it is sunny, and today is sunny because it's a good day. And humans are perfectly happy with that kind of circular logic, and the system has to be able to accept it and respond to it. You can't. I had a system that simply disallowed you to put it in, and essentially, if you said, bird is a bird, it would say you can't put in something that's as part of the hierarchy, but it kind of eventually prevented me from doing things that I really wanted to do.
Yeah, my opinion is that we should only allow this kind of loops when there's greater than or equal to two states.
I agree.
We
A
shouldn't have too
bird
many
is a
self
bird is
loops.
not,
Yeah, right,
bird is a bird is not terribly useful information.
right. Or dog is a dog is a dog is a dog. It's not really
Yeah,
useful. So
exactly. I don't think there's a problem in that. Just poking around though, you should be aware first, if you want to load this up, be sure to uncheck auto refresh on this, because there are some of these categories that have many, many, many entries, and the refresh interval on the dialog box doesn't give enough time for the system to actually reload the tree, and it really hangs the system. So turn off auto refresh, and let's just pick up a few other random things. There's an instrument, and this looks all pretty logical. I'm happy with this, and I mean, to some extent, you have to. I'm looking at this as absolutely phenomenal. This is totally excellent that we can get this kind of useful information that's mostly correct. And then the only problem that we run into is, and I saw this when I was looking before, is if I look at organ, and now under an organ, the system has very consistently said, the word organ typically means a part of the body. And so I have to say it's consistent. It hasn't interchanged pipe organs and livers. It's just confused the parentage a little bit. And I'm just curious, if I say what is the parentage of an organ, it says it's only an instrument. So what I would hope is that organ would have dual parentage to show that it's got two really distinct meanings and inheritance trees. And so anyhow, the question is, and I really hope that all of you could load this file and poke through it and see the kinds of things that are in it and the kinds of things that you would like to see better. And on one hand, of course, William wants to get a project that's defined and has, a starting point and an ending point. But the reality is, I think that we could play with this for a year and continue to add little pieces to it. But right now, this is, by the way, is only the second cut. William did a first cut with 5,000 words, and most of them ended up being unknown objects. And this is his second cut, where he subsequently looks at unknown objects and calls on them too, and tries to give a better hierarchical parentage to the entire system. So this is only cut number 2. So we've barely scratched the surface of the sorts of things that we can get out of this system. Any questions? Okay, well, we'll move ahead. This is next topic is one that's very near and dear to both Ida and I, and I want to thank you generally for the input, and that is that we now have modules written in Python, or can be written in Python. And before we dive into this, I want to point out that until I started working on this feature with Ida, I'd never written any Python at all. And so
now you're better at Python than me, so.
I'm really good at script kidding.
Yeah, wow.
But the styles, I haven't learned the Python style. And so as you look at the Python code, it is really, some of it is really ragged.
Well, you certainly figured out more about tkinter for GUI than me, because I mean, yeah, it's only been like what, 2 weeks since you play with it, yeah.
Well, the secret is that you have to see how it's really just the same as WPF with different names and slightly different capabilities. But underlying, it's all running on a Windows graphic system, and I know how the Windows graphic system works. And so I see it as a library for calling the Windows graphic system. And oh, by the way, it can also call the Mac graphic system, which is a real improvement.
Right.
Okay, so let's dive in, and I'll show you really what's going on here. We're going to share the screen again. But this time we're going to work from here, and we're going to stop debugging the program we were debugging, and we're going to change to the branch of main window. Now in main window, here you can, we didn't talk about the solution, but here we've got the UKS. This is a DLL. And because it's a DLL, and because we have a library called python.net, anything that's exposed in the UKS is directly accessible from Python. We have a project called Python project, and in it there are a bunch of Python files. And we can turn, say, to run a Python file by itself. Before we do that, let's run the main program by itself, because if we go to Brain Simulator, Brain Simulator is now the active project. So if I simply start it, we should get this version of the Brain Simulator running. And I'm going to, oh, I know why it didn't work. File. We have to open a file. Okay, look at this. It looks just like it used to, only it's different. And now we can add a dialogue and a module, and this dialogue is in Python. And here it is, and it looks just like the other. And we can say, if we expand the unknown object so we can see the result, that's the wrong thing. My trackball has suddenly gotten really twitchy. Let me see if I can zero in here. There we go. Look, it does exactly the same thing, just like we would hope, except this is written in Python. And the Python for that module looks like this. And, oops, missed again. Here, essentially, it's got this stuff that sets up the dialog box in gory and unpleasant detail. And eventually, it does a submit input. And the submit input is where, here it is, it gets the stuff and it calls UKS add statement in a single line of code. So this is all it takes to talk to the UKS. And so you can run queries and add statements just like this with a single statement, and everything else is eye candy. And we have only written two and a half modules. And there's this add module, and there's a display. And this is essentially another UKS display. It does exactly the same as this, only less. And we'll talk down after we get some experience with it. We'll decide whether or not we are interested in spending the time to make it do all of the things or not. So we can say Rover is a dog, and Rover shows up here, and it shows up there. So this is automatically refreshing itself. It's doing exactly the same sorts of things that the C# version of this dialogue is doing. And as I say, only less. And so what we've essentially got is a mechanism that uses C# and Python interchangeably, and the Python modules are hiding here in a project called Python project. And the neat thing about Python project is if we stop debugging this and say this is my active project, and I think you can do all of this in VS Code, but I'm not entirely sure. But I think you can. And now, if we do a start, let's do this one. New solution, set a startup file, run. So essentially, it can start up this module in a standalone mode, and you can debug it and step through it and do whatever you want. And essentially what we have here is just as if you fired up Python with this Python file. It's not doing anything else, although it still has the capacity to talk to the UKS directly, but there's no direct way of seeing the result because here we're only running a single module. And the way this project is set up, these modules are replicated in these other places, but they're only replicated as links. So when you modify this Python file at any of these locations, it's always the same file, and the change is automatically propagated everywhere. I mean, there's only one copy of the file, and it does only that one thing. In this, and so I've tried to set this up in a way that is, reasonably foolproof, that if you edit your file here, you can run it by itself if you want and make sure it does what you want. There are a couple of tricks, and one of the things you've been asking about, Yida, is this one, where in order to have the program work in a standalone mode, I had to call main loop, but main loop is blocking, and we don't want it to be blocking. And so this checking for argv0 is a way of determining whether or not the program is standalone or has been called by C#. Because when it's called by C#, argv0 is empty. If it's called by any other place, Python automatically sets argv0 to be the file name. And so that's why that is the way it is. There may be a better way of doing that.
I mean, this is simple enough, so yeah.
It just seems a little dopey. Another trick is if somebody closes the dialog box, you got to be able to know. And so the C# is repeatedly calling the fire command, and then it calls to see if winfo exists. Now, winfo exists is supposed to return information about whether or not the window still exists, but it doesn't. It throws an exception, which is just as good, but this thing, although it claims to return a Boolean, it either returns true or it throws an exception. So you don't have to figure that out. So we don't yet have a template for creating modules. And I think over the next week, we'll come up with a number of this is the exposed interface, that there's an init, a fire, a get-hwind, which is a Windows-specific hack that's necessary, a set label, and a close. And I added the init because if you close and reopen a module, you have to be able to reinitialize it. When you close a dialog box, the code doesn't go away, but you have to be able to reopen the dialog box, and that's what this does. And it uses a global because I couldn't figure out how to not use a global because I'm not used to Python. But over the next short period of time, we'll learn what is the full suite of things that a module needs to be able to do. And we'll create a template Python file that will automatically take care of everything you need to do. So you just fill in the functionality in the fire command and you get everything you want. And in the build, you'll set up the dialogue that you want to display and everything is going to work. Okay, the last piece of this pie is BrainSimMAC. And before we go further, perhaps Yida, you can show this in action. Can you share a screen and show this run?
Yeah. I'm not confident because it takes a couple tweaks.
Well, that's okay. This is based on code that I shipped to Yida late last night. I only shipped the instructions on how to make it work this morning.
Let me check out the branch first. Okay, then now I'm a command line person, so I don't know. I'm probably the only one here, but
I think that we'll find that most Python people turn out to be command line people.
Well,
or many
yes, yes
of them.
And no. Yes and no. If you use Python for deep learning, especially when you have to train models over some GPU cluster, then you have to remotely access some Linux machine that has GPUs in it. So you're kind of required to know all the command line stuff, but in Linux. And just it kind of just becomes a habit because Linux and Mac OS are so similar. Anyways, what I would need to do here instead of clicking buttons is, oh wait, first of all, I need to make a couple changes. Why don't I reshare the screen after I'm done with the tweaks, Charles, and then.
Okay, well, let me show it running on Windows.
Yeah, it'll take like a minute, so yeah.
Sure.
Yeah.
So I'll show us that it absolutely runs on Windows. And so we'll select BrainSimMAC. And the problem of, well, first we make it run. And here it shows me a dialog of available modules. And if I click on them, it will open them. So here's the tree. And here's the add dialog. And we can once again say Fido is a dog. And if we looked in here, we'd see yes, sirree. There's a dog and Fido is one. And we can say Rover. And there's Rover is a dog. And so we're doing exactly the same things, except this code will run on a Mac or on Linux or almost anything. And the secret that we've learned is you can write C# and lots and lots and lots of it works completely unmodified on many different platforms. And the secret is that you load up the .NET library, and the .NET core library is multi-platform, and then you can load up your C#, and as far as I know, you don't even have to do a rebuild because C# is this quasi-compiled intermediate language system, and when you send an executable, it's actually got the C# intermediate language in it, which can be recompiled to the target or not. But the part of this that does not work on other platforms is the entire GUI. And so we have a slew of C# GUI thingies in Brain Simulator, and these do not run on the Mac. And we will decide as we go along how excited we are about migrating this stuff to the UKS. I mean, to the Mac version. So we've got BrainSimMAC, and BrainSimMAC only has one source file in it, BrainSimMAC. And it calls the module handler, but the module handler is shared between the Mac and Windows version so that modules will be handled in exactly the same way. And it would be able to run C# modules if they have no user interface. And so this is a very simple little C# program that figures out what modules there are. Right now, there's no way to load a file, but I can imagine about a 5-line Python module would, if we write it, I would expect to write it in the next couple of days, would show up on this menu just by dint of its existence. And when you enable it, it opens up a file open dialog and loads the content of the UKS. So you can have a save and a load UKS content that should do everything you want. And I should point out as a extra feature, if you click on this again, it disappears. And you can turn it off and on all you like. And it seems to work. That's what the init function does. And so you can easily imagine a scheme that has 100 modules with little agents doing lots of little things, and you can enable them and disable them as you like. You ready to rock, Ida?
Yeah, I can share screen now.
Okay, go ahead.
All right. Okay, so let's see. Basically, I had to change a couple lines of source code, which is never recommended. So I'm gonna figure out a way to wrapper this either with a bash script or, well, we have to figure out the platform independent thing first. But after that, I had a bash script from the other branch before, but for this branch, I haven't gone that far yet. But anyways, after tweaking the source code, which you're not supposed to do, for demo, basically the thing is built, and from command line, let me just build it again. So we're in the BrainSimMAC directory, and you want to have .NET set up on your Mac so you can run this .NET build and that CS prod file. So that one. And I already built it, so it's just going to show you success again. And then we have to go into the bin directory all the way down to net 8.0. And here, my terminal is color coded, so that's good, because that tells me that that's the one that I want to run. So I'll just do dot means current directory / BrainSimMAC, and I run it. And here it is. Here it is. And the top one and the bottom one are the only ones that work right now.
Yeah.
So, but that'll be improved in no time. Yeah, and we'll just run the same. I think the color coding is broken again. I'll fix that. It's a tkinter level thing.
It's interesting. It works fine in Windows, and we know it's the same code.
Okay. I believe it's a level. I'm not gonna screw up the source code again, but
no.
But if you put in Fido as a dog and then you submit it, then you see that there's a dog created under unknown object, and Fido is created under dog, so that's great. And then we can say Rover is a dog, and then we got Rover here, and then we can say what Charles had before. Rover has 4 legs, and now we have legs, and I don't see Rover. Oh well, has 4 shows.
Yeah.
And
but
yeah,
the way the way this parses the content, if you put in spaces, is not implemented.
Oh, okay.
But it should be.
My bad.
Yeah, sure. But this is essentially, it's doing all of the same things, which is just great.
Right. Well, we'll just forget.
Can you close and reopen these? I'm just curious.
Yeah. If I click, I think so. Yeah. I click, disappeared. Oh, it shows in my main window here.
Oh, I see. You got to drag it back.
Right, and then click it, disappears, and then click it, shows up again. Same thing for the as statement.
Yeah.
I want to bring this to a higher level for Matej and Zaid, who are hopefully still listening, which is we're not doing the Python stuff to replicate. The purpose of the Python is not to replicate C#, is to be able to develop new modules in Python. But for debugging purposes, we replicated it just to show that it works as a proof of concept. But down the road, the purpose of including Python is not so you can replicate everything you're doing in C#. That would be pointless.
Right.
So yeah.
That's a very good point. Thanks for bringing that up.
Yeah.
Also, I should point out that when you said build,
yeah,
we made no change to say that you were building for a specific platform. You didn't say you were building for a Mac or building for Windows. So either the system figures it out on its own, or the exe file is essentially identical.
I think the .NET I installed on my Mac is specific for Mac OS. So it's all under this hood here.
Yes, right. But we didn't have to fool with keeping track of what platform we were targeting.
Right.
Now,
right.
In some of the software, I have used if-defs.
Oh, okay.
And it's only that things like message boxes for error messages don't exist in .NET for the Mac.
Yeah.
And so essentially those are all just suppressed in the non-Windows version.
I wonder if is Bash script a thing for Windows, or is it called something different?
I don't know. What does that mean?
So you can write a blah 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 .sh file that kind of wrappers how you want to run, say, Python file. So if you want to say python.mainwindow.py, and then you include like 20 arguments after that, you don't want to do that every time. So you put all of them together into a .sh file, and then you just run the .sh file. Yeah.
Yeah, there are Windows PowerShell scripts.
Right. Okay.
That sort of do the same thing.
Right. Okay.
But because I'm such a fan of Visual Studio, I never go near them.
Yeah.
But as you play around a little more with VS Code, you might find that it actually works really well. And oh, by the way, for debugging, the easiest way I found to debug a Python script first is you run it by itself. But if you have to have it running within the module environment,
Mm-hmm.
you insert a breakpoint in the source.
Yeah, yeah.
And it breaks off into PDB, which is, it's a clunky command line thing, but is so much better than print statements.
Yeah.
And that's worked really well for me.
Yeah, yeah, yeah. I'm a fan of debuggers too.
So anyhow, as we wrap up, I think you can see there's a huge amount of progress that's been made here over the last weeks, and some of it is directly related to AI in the way that we've got more content coming into the UKS, and some of it is a step sideways that is really important groundwork to move to multiple languages and multiple platforms, because AI, a lot of AI is done in Python, and a lot of AI is done on platforms other than Windows. And so I'm sure glad that you came in so that we could, I could get the support to be able to make that motion forward. But over the next month, we'll be having a lot more progress on the AI front rather than the platform front.
Yeah.
And I wanted also to thank you for getting that off the ground. That was really helpful because, of course, I couldn't do it.
It's barely started, so
yeah, yeah. Well, and also, I mentioned this in the email I sent out, that this had a lot of overview to it, but when in 2 weeks we're going to have a real technical under the hood. Let's solve some technical problems and talk about what is the template for a module really, what does it really ought to look like, and what mechanism should we have, and do we want to rename a bunch of stuff, and having things named main window is makes sense for for Windows, where everything is named main window, but not so much for Mac. And I also wanted to ask people in terms of the general communication, if we should start putting documentation on Wiki, on GitHub, and ditto if we should set up an online discussion there. And I'd be thrilled to do that, but we need to have somebody who kind of oversees it and looks at it, because the last thing we want is a bunch of unanswered questions. That's
right.
A good way to send people away.
Yeah.
And so we'll be meeting again in a technical environment in 2 weeks, and then again in 4 weeks for a more general group. And do you have any closing comments?
No, I mean, there's a lot to be done, so.
Yeah. Hey, it's really exciting, and I want to thank you, and I appreciate everybody's help, and I look forward to talking to you again. Okay. Bye-bye.
All right.
Thank you.
See you later.
Bye.